Hello learners, welcome to the session on Machining Operations Part 2, Module 5, Elements of Mechanical Engineering. Syllabus has mentioned the lathe, specification and its operations, milling machine, the principle and its types along with its processes. And the second part has CNC and robots. In this video lecture, we are going to understand the principle of milling and its types of machines and the working of the machines along with its processes. Let's begin. Milling is basically a machining or a material removing process. It occurs due to the cutting action of a revolving cutter. There is a cutter which keeps constantly rotating, and when a workpiece or the object that needs to be worked is fed past it, the cutter which is rotating, there is teeth on it. Each teeth removes a small amount of material or the metal in each of its revolution. The milling machine has a higher material removal rate and is widely preferred than other set of machining operations. A milling machine in its form looks like these. The principle of milling involves the metal removal taking place due to the cutting action of a revolving cutter, which is already mentioned. What happens is the revolving cutter is held on to a spindle and the workpiece is clamped rigidly onto the table. The cutter rotates and removes the metal of the workpiece in the form of chips from the surface of the workpiece. The method of removal of the material involves either giving the feed in left to right, that is upwards, hence called up milling, or from right to left, that is downwards, hence the name down milling. However, down milling is usually preferred as the cutting forces are reduced to a larger extent when the machining operation is in progress. The various types of milling machines are majorly classified into horizontal milling machine and a vertical milling machine. In a horizontal milling machine, the spindle axis is horizontal, you can see here, and is in the same plane as that of the table. Whereas in a vertical milling machine, the spindle axis is vertical to the table. The various parts of a horizontal milling machine include a base that supports all the other components, the column that contains the spindle and its driving mechanism, the overarm that provides the support for the arbor or the spindle, the knee, that is a section attached to the column which can move from top to bottom, that is it can move vertically, the saddle supported by the knee which moves to the left and right, that is horizontal, and the table which supports the workpiece and can move horizontally based on the saddle movement. Whereas in case of a vertical milling machine, the components are all as same as that of the horizontal milling machine, except in case of a horizontal milling machine there is an overarm, whereas in a vertical machine it is a spindle head. The spindle head holds the spindle which is normal to the surface of, which is normal to the machining surface. The difference, as I said, in a vertical milling machine is this positioning of the spindle. The spindle axis is vertical or normal to the machining of surface. The overarm and arbor is not present in a vertical type of milling machine. The milling cutter is directly mounted onto this spindle with a certain set of spindle attachments. Now let us look at the various operations on the milling machine done. The first one is the plane milling. It is also known as slab milling. It is basically an operation of producing a flat horizontal surface parallel to the axis of the rotation of the cutter. The material is removed from the upper surface of the workpiece. The required depth of cut that is needed can be adjusted by raising this table or the knee, and the feed is given by moving the saddle. In the end milling, the operation is done to produce a flat surface or a pair of flat surfaces using an end cutter, that is, wherever the edges needs to be worked upon is done using an end milling process. The surfaces that are produced could be horizontal, vertical or inclined with respect to the machine table. The slot milling is basically a process of producing grooves or keyways and slots of varying sizes and shapes. These slots could be of different size, that is a T-slot, a dovetail slot and any other slots. The side milling cutter is mounted onto the spindle of a horizontal milling machine. Usually the T-slots and dovetail slots are produced on a vertical milling machine. The angular milling machine involves the generation of an angular surface on the workpiece. The angular groove that are produced could be a single angle or a double angle. Example include a V block that could be produced using an angular milling operation. In the form milling, it is a process of producing a complex profile on the workpiece. It is usually carried out on a horizontal milling machine. Although these form cutters are very expensive, but on a milling machine, if there is a need for a complex profile, form milling can be utilized. Straddle milling is the operation of generating two flat vertical surfaces on either sides of the workpiece at the same time. These cutters are mounted onto the spindle or the arbor of a horizontal milling machine. The space could be varied by using spacers and the operation can be performed. Example, the figure here shows the production of a engine component using a straddle milling operation. Gang milling is very much similar to the straddle milling, but there are no space collars provided. Instead of the space collars, there are additional cutters attached to the same arbor. The size of these individual cutters could be the same or it could be different depending on the profile of the product that is needed.